So welcome to this side event on the Eurodata Cube. The title is Furnishing the Earth Observation Workplace with Data and Tools for Effectiveness and Production. My name is Bente Liljaby, and you will see me here. Welcome. We have a wonderful panel of experts today. And you will learn both from those who have developed the data cube, and you will also learn from those who have used the data cube, the European data cube. So I will quickly introduce them again with the slides. My name is Bente Liljaby. I am an Earth observation expert myself. But today I will be your moderator, and Gerard will actually here introduce the topic for you. So I will go back and show you the program. So first, the speakers. We will focus around the speakers. The expert who developed this fantastic tool is Gregor Milczynski from Synergize. He will give you an overview. Then Stefan Achtnit from EOX will talk about the Eurodata Cube as an open collaboration platform. So that's the technology part. Then we have some users. Anka and Helena from ESA will talk about COVID-19 dashboards. Then we have Katarina Yupova. She will talk about GeoRise, their GeoRise initiatives. And then last but not least, Henrik Fisser will talk about truck monitoring use case. So the moderator, this is me. You met me already from a small company, a micro company, that's the new term, BLB. And then, of course, our host and organizer, Gerard Tribnig from EOX. And I think you can take it away from here. Gerard will then introduce you to the topic of this side event, and then we will get into the program. And the speakers will let you know a little bit more about themselves before they start their presentations. So I will stop sharing. No, I will not stop sharing. I will give you this, Gerard. And maybe you are able to speak, Gerard, are you?
Yes, I am.
Yeah.
Thank you, Bente, for being our master of ceremony today. Good morning also from my side. I'm Gerhard Triebnig, CEO of EOX, and it's my pleasure to contribute a few opening remarks to this side event. First of all, I would also like to say hello to all speakers and to the folks in the audience. Let me check. We have at the moment 48 people participating, listening in to us. 48, which probably is even still to grow. I think it's remarkable, given the fact that there is a workshop running in parallel to this side event on the very important subject of artificial intelligence for Earth observation. To the audience, please use the chat channel to post your remarks to the presentations and ask your questions. We will try to answer them either directly or after each speaker has finished its presentation, or at the end during the question and answer part of this event. Now, the Eurodata Cube initiative fits very well into the digital twin Earth overall topic of this year's Phi-Week. Eurodata Cube can be explained as being kind of Earth observation information factory. It allows to combine really big amounts of input satellite measurements and of auxiliary data stemming from various sources. It converts these data through different IT mechanisms into what we may call application-ready output. How this works will be explained to some detail in a few moments by our speakers, Gregor and Stefan. In that, Eurodata Cube is an enabler of solutions which are based on the information contained in the satellite observations, giving digital twin evidence on the processes happening on Earth. Today, we will get 3 examples of such solutions presented to us by Anka, Katharina, and Hendrik. Ultimately, the goal is to support decision-making based on geospatial information delivered from space. Before I hand over to our first speaker, Gregor, let me also mention that today in the afternoon, there will be a second side event related to EuroDataCube, a tutorial and hands-on training where even more information on the practical use of the portfolio of data and tools offered by EuroDataCube will be communicated. Now over to our first speaker, Gregor Milczynski. You are made presenter.
Thank you, Gerhard. So the presentation should become visible in a moment. Can you just confirm that you can see it?
We can see it.
Yes.
Okay, so hi everyone. My name is Gregor Milczynski. I come from Synergize, Slovenia, and I'm in Ljubljana, remotely connecting to this event. Now, I'll give a short introduction to the EuroDataCube, then passing the floor to those who are actually using it to share their experiences. Now, at the start, let me just say that even though we are at the Space Agency's conference, what we are doing is not really a rocket science, right? What we are doing is a set of tools which empower other users to actually get some value out of the Earth observation data. Now, these users can be the beginners who might actually not be capable of working with this data where they're not for our service, to the advanced experts who could use something else or do it themselves, but they choose the service for different reasons, either for convenience or for cost efficiency, or maybe just because they prefer to work on the part that is adding more value than just processing the data. But one way or another, what EuroDataCube is really how users are using it, not really, I mean, it doesn't make sense if it's not used. And going through some examples of such use, anyone on Twitter, I'm sure you are familiar with Pierre Marcus, also called the wildfire guy. I mean, what he loves to do is to raise awareness about the wildfire, and he's doing that by creating images, very telling images that have now been featured on various media outlets around the world. And he really became famous. He was even noticed by United Nations, and recently one of his images was featured on the front cover of probably one of the most important reports this year, the IPCC report for 2020. Now, another example of how users can be engaged with the service are the Sentinel Hub custom script contests. In the last 2 that we run, we collected about 50 different scripts from people from different backgrounds, both the experts and non-experts, and they really come up with the great ideas. On the left side, we can see the hurricane damage. On the top right side, the clear cuts in the forest and the burnt areas, and the chlorophyll levels in the lakes. I mean, there are really lots and lots of different ideas, and they are done by the people who, many people who didn't really work with the satellite data beforehand. Now, when the COVID started in spring, ESA wanted to engage citizens to come to analyze the data and come up with their ideas on how to monitor the impact of the COVID crisis, right? And in about 2 weeks' time, they managed to set up this contest in operation, providing tools to anyone in the world so that they could access the data and then prepare the ideas. And they got quite a few very good ones, some of them becoming so mature that they are now used in an operational manner. One of them that I liked really a lot, or maybe even the most of this, was an example by Henrik Fischer, seen here still in the forest, but very soon joining us in this studio. What he did is he converted these rainbows on the roads into basically a statistic of the number of trucks on the roads in Europe on the European scale. I really found this amazing, as it was such a simple idea, yet so powerful. Henrik will tell more about it later on in this session. Then there is a race dashboard, which was another opportunity where ESA wanted to do something very fast. Basically, they came up with the idea of the dashboard, and they wanted to have it running in 1 month. And I think, by the way, Gerhard or someone, there is noise, so maybe you can mute yourself. So ESA wanted to have this idea running very fast, and they made it so by using the facilities that were available by the Eurodata Cube, as long as a lot of other effort, just to be clear, right? But Anka will tell a lot about it again later on. Then you have large corporations using the services. In this example, TomTom, who is, I mean, they are orders of magnitude bigger than we are, and they have lots of developers who could definitely build this kind of tools by themselves. Yet they chose to use the services in a pay-per-use option, probably because they realize that it's better to focus on things that are adding most value from their knowledge. And what they did is that they created a global scale world cover, not unlike what ESA is trying to do now with the world cover project, right? But they did it internally, mapping the land cover classes, and therefore, because it was funded internally, they had to be really careful about the costs and so on. Now, last but not least, you have scientists who found penguins in Antarctica using our tools and looking at poo. I mean, who would have imagined something like that a couple of years ago? And these were just a few of the examples, a few that we could share. There are tons of similar things. Some of them we cannot share because of the classified nature of cooperation. Some of them simply we don't know because the users don't need to tell us how they use our services. And for many of them, there's simply not enough time to expose them in this way. But there really are lots and lots of users doing different things, unimaginable things with the service. I want to use this opportunity to also notify everyone that there is a Sentinel Hub custom script contest running right now with the deadline at the end of October. And we had an early bird submission in September, and the winning script was this reactive algorithm by Thomas and his colleagues. And again, it's a very nice example of how you can make something very complicated, in this case, a multi-temporal series of radar data that, that is difficult to comprehend by itself, into something that is really optionable, right? You see where the changes are happening, and the script is so simple that can run in a EO browser. And I congratulate them for this award because, yeah, they really put an effort for that. Now, the Eurodata Cube itself, it's kind of the middle tier between the satellite data, which is probably one of the most valuable resources we have had in the decades, and the cloud infrastructure from different providers on one side, and then the application developers on another side. The application developers who use this data and services to create some products for the end users, either the policymakers or farmers or whomever. But it's very important that there always need to be someone who kind of who takes this data and translates them into something that is useful for a specific use case. Eurodata Cube is combined of several parts. You have it deployed on several clouds, both the Diocese and Amazon. We try to make use of all the data that is available so that we can really make this data available to the users, both the satellite data as well as the non-EO data. And then you have on one side the data processing and analyzing services such as Sentinel Hub, Xcube, and GeoDB. And on another side, you have the processing and collaboration environment powered by UX Hub Workspace and Jupyter Hub. There are also the algorithms and applications and data sets that were put in by other users, not by us. And again, many of these can be used and reused by third parties. These services are exposed to users via a set of APIs. We try to use OGC wherever possible, but then sometimes we go beyond of the capability of the OGC standard. So we have our proprietary APIs as well. And because most of the data science in Earth observation is happening in Python these days, we put a lot of effort to make the use as easy as possible in Python, building libraries and SDKs and so on, so that you can really do whatever you want there. Now, for data access and processing, I certainly hope that everyone listening to this session know everything about Sentinel Hub already, about the API which provides instant access to the data anywhere in the world for any data set for any time period in a way that fits the user, right? Whatever is a convenient format, it's supported there. And while providing data, there can be some processing applied to it, from simple composites and indices to a more advanced neural networks such as leaf area index, FAPAR, and alike. We have a couple of hundreds of these algorithms available in an open source nature on GitHub, so that people can start somewhere and then modify them for their own use. You can do multi-temporal processing like this one, using the normalized burn ratio before the fire and after the fire, and then creating a simple script which compares these two and results in a impact, in a demonstration of impact where the fire was most damaging and where there was no impact at all. You can do data fusion, like in this example where we use Sentinel-1 data for building area identification, and then Sentinel-2 for the rest, or here for ship identification and alike. And this is a bit more advanced example where we use Sentinel-2 data for creating an NDVI in the places where actually it's possible to get an optical, where optical data has some value. But then in the parts that are covered with clouds that are invisible to the optical sensors, you can use the Sentinel-1 derived NDVI-like index to generate a similar variable. When we see how Sentinel Hub is used in a machine learning processes, where you have it really operated on large scale, running millions of requests, and then doing some further steps like interpolation and harmonization of data, we realize that that's something that we can support users further. And we created batch processing, which basically offloads even some more work from the users, so that you can configure how you'd like to get the data. You can configure these interpolation steps and harmonization step, and then you simply define the area of interest and time range, and then you set it running. And in a couple of minutes or a couple of hours, if it's a larger area, the data will appear on the object storage, and then you can take them over in the follow-up processes and work with machine learning tools on them and so on. Now, if you want to do advanced processing and analysis, there is a Xcube ecosystem available, full of open source tools, not just developed by us, but also by the rest of the Python community. Everything nicely integrated so that you can really build powerful processes on top of it. We integrated Xcube with Sentinel Hub so that you can get this instant access to the data through the Xcube interface. Or if you want to do the permanent data cube, there is an Xcube generator, which you simply, again, define the area and time range, and you will have it running. If you're working with non-gridded data, such as labels and administrative data sets, there is a GeoDB to store it and to make them available. For exploitation of this data, you have Xcube Viewer if you just want to visualize this data. But then if you want to do some processing, you can do it either in Jupyter Notebook or in Python scripts. And then when you are happy with the results, either the data or the processing, then you can use the Xcube server to expose this as an API to whatever application needs this data. I'll not go into the details, the technical details of the Xcube, because the training, the hands-on training in the afternoon will explore many of these. But let me just mention that you can really do the advanced processing, even integrating the third-party libraries such as Snap processing reps and alike to create the data, then to feed this data into your process, do whatever you want to do with the data, and then either expose the results or feed them back in the loop so that you can go to the next level of processing. We put a lot of effort to make as much data as possible available. So we support all the Sentinels, Landsat, MODIS, digital elevation model, even commercial data sets for the moment, Airbus and PlanetScope, the non-satellite data such as Copernicus services, CCI, Earth System Data Lab, even LPS data and alike. And we are putting an effort to get more and more on board. And whenever there is a data set missing, you can use the bring your own data option and simply get your data and then use it yourself or share it with others. Most used data sets obviously are Sentinel-1 and 2, so maybe a few words on that. For Sentinel-1, it's worth to mention that we can generate Cart4L ready data, like including the order typification, RTC, the backscatter coefficient. So you can get this directly from the API or through Xcube in your system. For Sentinel-2, we have the level 2A archive, which is even larger than what ESA processed. It goes back to beginning of 2017. And in addition to the sync classification cloud mask, we also have S2 cloudless masks so that it's really easy to mask out the cloudy data so that they don't cause confusion in the follow-up processes. And then when you enter into the processing and collaboration part, there is the Xcube workspace, but I'll let Stefan, who is following me, to say more about this. And let me just provide a glimpse into the use of these services so that you see the scale of operation and that you see that this actually is used and it's used a lot, hopefully guaranteeing that this will live for many years on to come. And now at the end, let me just mention that all of these services can be used simply by going to eurodatacube.com and entering in a free trial by just entering your email. But then if you want to build something larger, both for the research or a pre-commercial exploitation exercise, there is a ESA-sponsored option available at this link. So you just go and enter your application, what you'd like to do, what kind of services you'd like to get. And ESA is quite efficient in approving this or communicating further details. So thank you very much for listening, and I'll give the word back to Gerhard.
Yeah, this is not Gerhard, this is
Over to
Bente.
Bente, over to Bente.
We work very closely, so yeah, thank you so much, Gregor. If you have questions, as we said initially, if you have questions to Gregor, please write it in the chat box. Otherwise, we will also be able to discuss. I think we have set aside about 30 minutes for discussion at the end. So you will have time to ask questions then as well and join in a group conversation actually. But do feel free to ask questions in the chat. And if you will be too late until now that I give Stefan the floor, we will be able also to answer your more technical questions immediately after this technical introduction. So after Stefan. So don't be shy, ask questions or comment for that matter. Okay, Stefan, you are ready to take the floor and introduce yourself shortly as well before you start on the presentation itself. The floor is yours. Maybe you have to unmute yourself. Yes, Stefan, you have to unmute yourself. Or maybe, yes, you are, yes, there you go.
So I'm unmuted, great. Yes, so hello, my name is Stefan Achtsnit and I'm working together with Gerhard at EOX to tackle the current challenges with Earth observation data and processing. So the title of my presentation now is EuroDataCube as Open Collaboration Platform. So open collaboration, it's a claim, a broad term. So before I start with my overview slide, my agenda slide, let me put two other slides before. First of all, this first slide, I think you already saw it before. So this is our common introduction to EuroDataCube. So it's EDC, EuroDataCube as middle layer, as the middle tier sitting between the satellites and the solution, consuming the raw satellite data, leveraging a runtime environment, as a cloud infrastructure, and to bring the applications, to bring the solutions to the people who finally make the decisions. And we at EDC, we try to support the full solution lifecycle to creating a solution, running the solution, and even promoting and selling a solution via the EDC marketplace. So you can say all the batteries are included in EDC. So we handle the data access, we manage the processing, we take care of the deployment, we can handle the operations for you on top of the underlying runtime, the cloud infrastructure. And on the marketplace, we give a public face to your solution. And we can promote it, and we can even put a price tag on it if this is desired. And let's come from a different angle now. So on slide 2, let's say you already know which problem you want to solve. You have enough insights to understand what is needed. So you already have the idea, like for example, Henrik Visser with his idea to sense road cargo by detecting trucks using Sentinel-2 data. And this was, as Gregor already mentioned, an idea he worked on during one of the custom script contests earlier this year. And I would say he was quite successful and got great results. So great, congratulations. And what was also great is that he decided to share his work, his algorithm. And this was something he did on the EuroDataCube marketplace as a Jupyter notebook. So if you are interested, just head over there. So perhaps better not immediately, but after the session, and check it out. There it's listed under the Jupyter notebook session, and you can see Henrik's contribution. And this allows others to understand what he did. And I think what is even more important in the scientific spaces, it allows others to reproduce his work, because the notebooks, they are executable and you can run them yourselves and validate the approach. And you can even further collaborate and iterate from his ideas and improve the things there. And in this concrete case with the truck detection, Henrik continued to work on that problem himself, also in the context of the ESA upscaling COVID-19 initiative. And there was this idea to apply this algorithm large scale, also to see the impacts of COVID-19 on road cargo traffic in whole Europe, with the goal to publish the final results on the European dashboard. And this is ongoing work, and I think Henrik and Anka, they are both also participating in this webinar today, so you can hear much more about that, about this collaboration efforts using the EuroDataCube capabilities later. Okay, so let's come to the promised overview slide. So what's on the agenda from my side today? So first, I will try to motivate how EDC tries to foster this journey from ideas to solutions. So you have an idea, you need to validate the concept, you want to formalize it, you need to formalize it, you make out a real process out of it, and then you want to scale it. You want to run a real workflow, large scale, which perhaps require gigabytes, terabytes, or even petabytes of Earth observation data to load, to process. And finally, yes, there was also a reason why you built all of that, because you want your work to be used to serve a need. So you need to promote it as an application and to publish it, for example, as an interactive dashboard application, whatever. So this is definitely a big task, but you are usually not alone. You work in a team, and these are definitely completely different work areas. So different know-how is needed. Perhaps for the first thing, you need a data scientist to validate the concept, a data engineer to build up the processing pipeline, the operations team to run your workflow large scale, and developers or a full product team to create a fully fledged application out of it. And yes, this can be done by people brought together within a single company, but in the same way, and as demonstrated with this truck detection solution, it can also be done between loosely coupled people. So they are just collaborating together in a specific program domain, but on the different individual parts of this. And in this sense, I try to motivate how EDC can help here, and how EDC can strive, how EDC strives to enable collaboration between these involved people in these different phases. So let's come back to the original slide and brand it slightly different. So EDC as collaboration space, where the involved people engage via one central piece, the EDC marketplace. And there you have all the linked pieces, the building blocks together. The data building block, also highlighted on the left, to search for EO data, to download EO data, to access EO data. And what's important, so we with EDC, we want to have a common abstraction of this EO data as a data cube. On the right side, the workload, with workload being everything. So this may be your full custom processing script, the data preparation task, a data pipeline, a machine learning workflow, or the fully fledged application I talked and mentioned before with the RACE dashboard. And there's the workplace component, the workplace building block at the bottom. Also, I usually prefer the term workspace instead of workplace. So you have a cloud workspace, a cloud runtime, helping you with elastic compute, with CPUs, with GPUs, with variable memory amounts, and with different storage options, network file storage, object storage, to run and execute your workloads in an efficient manner. So let's have a more detailed look now on these individual building blocks. Let's start with data. So there is a good rule, a good practice, this well articulated by Niall Robinson from the meteorological office in informatics lab. And he wrote, or he said, represent geospatial data sets as meaningful analysis-ready objects, not as a set of chunk data files. And I think this is important, and this is also the core philosophy behind Euro Data Cube. So Euro Data Cubes, these are cubes, and a single scene is just a specific case, a time slice in the cube. And if you slice in another dimension, you get a time series, for example, and so on. So the core concept is a model with a multi-dimensional array of latitude, longitude, time, and spectral bands. Plus, and this is important, it also should include the metadata, like the dimensions which are included, or concrete value ranges for the individual values. So from workload perspective, when you write your algorithm, your processes, you should always try to leverage this conceptual model of a data cube. But what about the physical representation behind? So how are these physical bytes of this EO data laid out? So there are plenty of ways currently in use. So X-array, for example, as a Python and memory representation. Then there are NetCDF, HDF5, SAR, TileDB, GRIP. These are not just multi-dimensional data formats. Some of them, there are protocols or even full data engines. What you also find quite often are all these I call them scene-based folder hierarchies, like on AWS with the open data initiatives there on public object storage, where you have Sentinel-1 data as JPEG 2000s. You have the Landsat archive as geotiffs. You have quite new, the Digital Earth Africa Sentinel-2 Level 2.8 data in cloud-optimized geotiffs, as cloud-optimized geotiffs, the so-called COGs. And you may also have your own list of single scene files with internal and external metadata, like commercial VHR datasets from Planet, Airbus, and they are staged into your object storage, or they are downloaded via FTP, WCS to be used then within Euro Data Cube as additional input source. So there are really many ways how EO data cubes are physically baked up, but unfortunately, this is, especially from performance point of view, this is nothing which can be completely abstracted away. So with all the data, EO data archives, as we are talking about terabytes, petabyte scale here, there always arises the question on data access and what is necessary to use them in your processing workloads. So is this specific data set analysis ready? Is it stored cloud friendly? Does it support partial data access like HTTP range requests? What about the chunking strategy? How is the data aggregated in the bins, for example, if there are overlaps? Or how you fill up the gaps, how you interpolate? So depending on the concrete use case and the consumption behavior, it is always, or it may be necessary that you prepare the data for efficient and cost-effective data processing. And this brings me to the next slide. So EO data preparation. So as just said, in the ideal world, EO data is analysis ready, stored in a cloud-friendly format, and always applicable to your use case, to your workloads. So it can be directly consumed within your workloads. But in general, there is no one-size-fits-all solution. So putting all up in object storage in the cloud, in a cloud-friendly format like COGS or SAS is definitely a good start. And to have something like the digital Earth Africa dataset for the Sentinel-2 level 2.8 data publicly available, this is really, really great. But if you need to calculate long time series, for example, requiring only one specific pixel of, let's say, 246 different individual COG files, you need to consider they are still stored per scene. Even if they are COGs, they are stored per scene, per timestamp. So you need to calculate long time series. Then for adequate processing performance, you probably want to rechunk the data upfront. And there you need tools, there you need help, and EDC can help with in that regard. But what's also important, and also what I want to mention here, EO data preparation does not necessarily mean EO data duplication. Yeah? So EDC provides a variety of options for pre-processing and storage, consumable through EDC Marketplace and demonstrated through Jupyter Notebooks. And there are options for both on-demand processing as well as data preparation, which really stages the pre-processed data separately. So I put the many options here as a reference. On the one hand, we have the Sentinel Hub API, which can be accessed via the Xcube SH client library. And this is also the approach Henrik used for his work. Then there is Sentinel Hub batch processing and the Xcube generator. And they are both externally managed, which means it's not your server, your environment, which prepares the data with all the pros and cons. But it's up to you. You have to decide if data processing is your core business domain, yeah? Your core working area, or if you want to outsource it and use a managed external service like Sentinel Hub Batch or Xcube Gen. And what you can also do is you can leverage the cloud processing workspace itself also for the data preparation step. And the EDC base environment, so it provides common tools, common libraries, and for EO data handling. And there are also plenty of we call them off-the-shelf choices. So if you want to use Open Data Cube, the OpenSAR toolkit, or Virus for Swarm, soon Virus for Eolus. So if you want to use them together with the EDC services, just contact us and just notice these are off-the-shelf possibilities. We give you a generic set of common tools on the marketplace, and the other things, just contact us and we can provide you with off-the-shelf solutions for your problem. So let's come to the EO processing workflows. Again, this means everything: processing algorithm, the data preparation task, the machine learning workflows, or fully fledged applications, and they are all executed containerized. This is important. So this is also one of the core philosophies of EDC. We try to package everything as a container and execute them in a containerized form. So you write them directly on IDC, either via the managed Jupyter Lab environment, or you can deploy them via the API. And for execution, for invocation, there are also different possibilities. You can invoke them via the Jupyter Lab environment itself, or you can invoke them in a headless fashion, in a headless mode via API. And we also support on-demand processing, batch-driven processing, or systematic processing. So this is up to you. And I think what's really important for workflow and workload processing is, I want to highlight one sentence from Mac Crystal from Google here. So more people will interrogate, use, and extend good ideas if they are easily reproducible. And this is what we are trying to build. So the EDC EOX workspace offering provides a curated set, a curated kernel with a ready-made base environment, including commonly used EO processing tools. So all these kernels are publicly available and they are regularly updated and they are versioned, so to foster reproducibility. And we have several of these example workloads published on EDC Marketplace, so you can install them, execute them with one or let's say a few clicks. And yes, we also try to make you a smooth experience, so we ensure that the things are working as they should, and also with updates, with new features. So here again, as I just mentioned before, and how we see your workload and how we anticipate your usage on EDC with them. This is demonstrated and summarized in this diagram here. Different types, different invocation modes. We have automatic ways to track the runtime behavior of your algorithms. And the final question, how you get the workloads on the platform. Yes, as just mentioned, you can deploy them either directly, interactively via the managed Jupyter Lab environment or in an API-driven way and execute them containerized. So let's come to the workspace building block. So cloud workspaces can leverage elastic and scalable compute layer with various storage options close to EO data archives for large-scale processing. Yes, this is the core EDC UX Hub workspace offering. So what does that mean? EDC offers a fully managed workspace environment in the cloud. So currently we are supporting AWS and the Mundi tiers, and for all of them, we support different storage options. We support file storage, block storage, object storage. Why these choices? Because your processing code is usually something you want to put on a file storage, manage via the file system, interact through with Git and other source control systems. For volatile data, like for data caches, you want high throughput, low latency, so use block storage for that. And for the huge EO data, satellite data archives, for this EO data, you want to leverage object storage. So this is our diagram which Gregor showed before, and I just want to focus now on this small part. So the workplace, the UX Hub workspace offering, bringing together the algorithms, the applications, and the data, which help you to manage your workload environment with the base layer, your processing code, and the data. The workspace manages your workload execution in interactive or headless fashion. And it manages access to the EO data cubes and auxiliary data. Yeah? So leverage Sentinel Hub services abstracted as EO data cubes. And this brings me to my last slide. So how the people are interacting and how the people can collaborate on the EDC marketplace. So what do you get there? On the one hand, you get automated provisioning of access for ordered services and commercial data products. You get a range of ready-made applications to view or to preview and analyze data, like the COC Explorer, that we have tools to the OGC EDC to preview it's a WMS visualization service. Then we have Xcube Viewer going directly to SaaS stores in the cloud. And we also have a lot of starter and collaboration tools to share best practices, like the notebooks I mentioned before. So just go there, look for algorithms which are interesting to you, and you can directly execute them, invoke them, and analyze them, and further collaborate on them. Yeah. So this is the way the EDC marketplace looks like, and I will conclude for now. So we all hope to see some of you collaborating on eurodatacube.com, and we are looking forward to your contributions. So head over and see you there. Yeah, thank you.
Thank you so much, Stefan. It is, of course, very interesting. I just reminded you that you can ask some questions in the chat at this point and discuss later. I have a question as Anka is preparing to start a demonstration of different views. Now we are on the technical part. So as I understand, when you are speaking about Earth observations, you are meaning space-based observations throughout here, right?
Yes. And
yes.
also with the time context, yeah. So.
Yeah, exactly. So it's, but of course there are many other types of data. In situ data is one description, or ground-based data, and auxiliary data. Have you any experience of connecting these type of data with the data cube as it is now?
Yes, so your data cube, we also have a service which is called GeoDB, which is our offering for vector data sets. And we have a lot of examples on how you can bridge, how you can link together these different data sets. For example, in the agricultural space, how to link the parcel information together with NDVI information from raster data sets. Yeah, so this is a common way, and there are a lot of good examples on the EDC marketplace available you can leverage to get started in this context.
Yes, and then I have a question. You mentioned several times, both Grega and you, APIs. Are we talking about open APIs, or, well, more specifically, can you connect with other platforms through a open API, so Open Search API, for instance?
Yes, I think search is an important part of the EDC platform, and we support different mechanisms to search for the data. And we now also have a stack compliant interface on the Sentinel Hub side. And this is also something you can leverage. And there's also an open search endpoint, or the older WFS.
Thank you very much. Anybody else?
We have a question. We have a question from the audience. Marco Wolzer is asking, thanks for the question. In terms of the underlying technology, what are the main differences or advantages in comparison to the open data cube? Who wants to answer this question, Grega or Stefan?
Maybe I can answer. So basically the Open Data Cube and X-Cube are very similar in terms of technology. Both are based on the Xarray in the backend, and many of the libraries can be shared upon. Where I think there is a major difference between the Open Data Cube and the Euro Data Cube is that Open Data Cube as such is basically a technology which you then need to operate by yourself, or somebody needs to operate it, whereas Euro Data Cube is an operational service where you simply use, right? So for example, if you want to use Open Data Cube over some area, you would need to first process the data to have it in for that area. And by the way, we have a service which can do that for the Open Data Cube. But in Euro Data Cube, you simply connect to the APIs and you will get the data there. Let me just mention that there are some questions in the Q&A section as well of the WebEx.
Yes, I was just repeating one question, because it's a bit stupid in this tool that only the panelists can see the questions and answers, and the audience doesn't see it. So that's why we have to read it again. There is a comment from Gunnar Brandt. Who wants to mention that? Gunnar Brandt, who is the brain behind the X-Cube component in Euro Data Cube from Borgmann Consult.
What is the question? You can read the question.
Well, it is a statement, actually. No, okay. We also have other data in situ and model data. So has been a comment to some of the conversation. I cannot connect really right now.
I think you.
Oh, well, I was asking. Yeah.
You can give the ability to speak to Gunnar if you want to provide him. But maybe while doing this, let me answer to some other question on the Q&A here. So there was a question of whether it's possible to do machine learning training on in-house service on our AWS instances. And the answer is clear yes, right? So we really wanted to leave all the options open. So this is why everything is built on APIs. So you can do it on your laptop, you can do it on your in-house or on Amazon, or you can use some of the virtual machines that can be rented through the EOX Hub workspace. So all of these options are open, and then it's up to the user to define which one of these fits them best.
Okay.
And then there is another question. Will it be able to charge clients? So it's on a business side. Will it be able to charge clients on the API access using our own EO algorithms and our data? And the answer is yes. We don't yet have the generic model for that, simply because the business models differ too much. But if there is a need for that by someone, we would definitely love to onboard these algorithms or data, and then we do have mechanisms in place to charge for them. So it is just to agree on the revenue sharing model, something like that. But generally, it's something that I think could be agreed in a couple of days, and then we just have it running.
So yeah, and we have Pedro also asking, what is, in your opinion, the best way to display images on a web application?
Depends how much control you have over the web application. I mean, the easiest way for sure is simply to integrate web mapping service. What we have an options to configure web mapping services on the backend, like in the Eurodata Cube, so that you can define how you would like to visualize the data. And then, I mean, more or less every GIS application I know has an option to add the WMS layer. So you simply expose this data over WMS or WMTS, and both of them are supported, and then you have it running.
Okay, thank you very much. I don't see any more in the list of questions here now. Gunnar, he needs to connect.
I've made Gunnar now.
Okay.
Unmuted.
Thanks, Gerhard, for unmuting me. So attendees cannot speak up for themselves. Yeah, well, as you said, rightly said, that was just a comment to, I think, Bente's question asking if it's EO data from space only, and I would wanted just to check and say no, because the first answer was yes. So we'll make quite an effort to also, for example, integrate Copernicus service data. Many of them are model-based, for example. And then in the clarification, the data was mentioned.
Okay. Thank you.
I unmute you again, Gunnar.
You will be given the possibility to speak at the end also, Gunnar. Thank you for that. Okay, so we now leave for now the technical introduction, and we take a look at how this technology has been used. So Anka, you have the ball, I can see, so the floor is yours. Introduce yourself and then the presentation. Thank you very much.
Thank you so much, Bente. So just a short introduction before I share my screen, while you can still see my face on your machines. So my name is Anka Angela. I'm an Earth observation open data scientist. I'm based here in Frascati. I'm with ESA Esrin working in the Earth observation department in the data applications division. And I've had the pleasure for the past months to lead, let's say, the development of this application that is the RACE dashboard, as we call it, or Rapid Action on Coronavirus and Earth Observation. And I'll have the pleasure to introduce this application that we've been working on. We'll start sharing my screen now so that you can see it. Can you please tell me if you can see it properly?
Yes, we can see full screen.
Excellent. Right, so there are actually, we've been working on 2 developments, but I will start because it's a single deployment in the end, so I will just focus on this Rapid Action Coronavirus Earth Observation initiative. This is an initiative that was started by ESA in collaboration with the European Commission in April, March. As you know, we're all experiencing now this global context with the coronavirus pandemic, and the European Commission and ESA really wanted to see how can we gain more information about the pandemic and especially about its effects. The whole world is focusing on trying to find cures, working on vaccines, trying to understand what is the impact on human health, and so on. There are also other consequences that we could see all of us all around us, let's say, in the economy, in the environment, and so on. So this is why this initiative was launched in a quite fast pace, let's say, and we aimed to provide really for the general public mostly, but also, why not, for decision makers, some means of gaining access to let's say, a more diverse range of information products supported by Earth observation data. So really the objectives of this initiative were to, as I was saying, to provide public Earth observation-based information on the state, the current state of society and economy. As we can see it, of course, from space, it is not really a comprehensive view, but we can see quite an impressive number of things from space, let's say. The main, let's say, the strong point that we brought on the table were the huge, let's say, volume of open data that is being provided through the Copernicus program. So the data from the Copernicus Sentinels, supported by data from third-party missions, were really at the core of this product. We're proud to say now, and I saw that this is a phrase that was caught up also in the media. This is a product that is made in Europe, and this is very nice when we think about all the companies that have been involved in the development and in the delivery of the data and the definition of the indicators and so on. And most important, probably, all the science teams that have been working on interpreting these indicators and providing, let's say, in common language, an explanation of how to read this data that is being made available. The product is focusing on a number of thematic areas. So we're looking at climate on one hand, and environment, but also at economy and agriculture. And I'll be showing some of these examples. We try to follow in the development a number of principles. So first of all, as I was saying also before, we're based mostly on one single source of truth, which is the Earth observation data that is coming from the Copernicus Sentinels and the third-party missions. It's a product that was, as I was saying, made in Europe, but it's supposed to be straightforward, so easy to use by non-technical users. And my presentation will be as simple as possible, because this is what we're really looking for, to provide information that is easy to understand and easy to grasp. It should communicate the effects of the lockdown on the environment and the economy. And now we've seen in the past months a start of the recovery. And now we're seeing again some countries going back into lockdown. So we're really able to capture all these ebb and flows, let's say, of this pandemic, as we can see them from space. And of course, it engaged a lot of the public and community, just the general public, general community of enthusiasts and practitioners through the Eurodata Cube contest and the upscaling competition. So currently we have a growing number of indicators about our economy, agriculture, and the environment. As you can see, the numbers on this slide are not really updated. We're actually in the middle of a deployment now of a new release. But the really amazing thing is that in such a short time, we were able to coordinate an impressive number of 31 companies that have contributed resources and effort to bring all this data together and to make actually this implementation. We've reached quite a large number of visits today, so we have more than 100,000 visitors, which is quite impressive for, let's say, a product that is based on information that is not really day-to-day accessed by the general public. So we read newspapers, but we don't really touch the data as regular citizens. And you can see all the companies that contributed here on the slide. But because we were thinking to make this product really to showcase in plain language, you know, how Earth observations can really give actionable information and information that can be understood by, let's say, by our families, we really managed and we succeeded to have a global reach. And you can see on this map all the countries on the globe that from which our visitors are coming. So we have almost reached the entire globe, and the story has been captured by quite a large number of newspapers and online journals, and this is really this makes us really happy, because this is the aim that we were looking for. try to provide an objective view of the effects of the pandemic. So this is the data. It's not something that that politicians are telling us. This is, let's say, objective source of information. So we showcase through this dashboard a number of real examples of the pandemic's effects. We have over 200 areas of interest defined all across the European Union, and a growing number of indicators. Today we have more than 130 indicators on air, water quality, agriculture, travel, manufacturing, and trade. And the thing that we're proud of is that we managed to get this launched in a very short time. But I do have to point out that this has been quite an effort, and it brought together, let's say, a good collaboration between the science teams, the developing teams, and the engineering teams. And really, it could not have been possible if we didn't have beforehand all the technology that is enabling us to do this. And I will try to review in my last slide the key points of the Eurodata Cube that made this possible to be launched within 2 months. I will just give a very brief overview of the type of information that is being presented. And how we rely on the data that comes from our satellites, especially from the Sentinels, to derive these economic, environmental, and agricultural indicators. So we use mostly Sentinel-1, or we rely on Sentinel-1 and Sentinel-2 due to their spatial resolution, due to their type of information, so type of sensing. But as well due to their frequency of acquisitions, we rely on them to derive mostly economic indicators, but not only. You can see in the first picture or group of pictures in the upper left corner, a Sentinel-1 image over an industrial area in Sweden, and maybe it's Poland. And this is a steel production facility, and we can see we can actually measure the amount of steel that is being produced and stored in the logistic areas in this facility, because this area is located outside, and the SAR signal has really bright reflections that is coming from all this metal that is being produced. So we can look at the variations in the production and compare it to a baseline. And we can do this because we have access to archive Sentinel-1 data. And you can, if you really zoom in on this graph, I don't know how much, how big you can see it on the screen, but the data goes back to 2019 on this graph, and it can go back even further. And we can see either increases or decreases, and we can derive significant statistical measures to understand whether the current situation is better or worse than the baseline that we have. Below it is an example of the activity that is being monitored in ports, and here we rely on Sentinel-2 data, complemented also by high-resolution imagery, to understand what is the variation in the number of ships that are being that arrive and that leave the port at dedicated piers where specific materials are being brought through or in context of imports and exports. And we can do this manually, or we can do this automatically. And actually, this is one of the progresses that we've made through the integration of machine learning and automatic ship detection. And maybe you can see the little orange boxes that are marking the detections that are being done on the image. And of course, again, we can make this comparison of the number of ships that is present at current date with the baseline that we have. And from this, we can derive valuable insight. And we're looking not just at steel production or ports, but we're looking at a wide range of other areas where the signals that we measure are sufficient for us to to be able to derive such information. Another example where we use machine learning and automatic object detection is for looking at parked airplanes in airports. There are also contributions coming from the community that I will not talk about today because we're working to integrate this and they're not integrated yet. But that will expand this area of information that we gather from air traffic. Sentinel-1 imagery is not really something that a normal person would look at and understand what is happening there. But I try to put this example because it's quite, let's say, dramatic, at least for a radar person. This is an example in a parking lot in a big commercial center. I hope that the video is playing correctly and you can see how the signal is changing. The intensity of the signal is changing between different dates, and this is basically what we're measuring with radar. Sentinel-2 has been one of the let's say important or most important sources of information when we were looking at monitoring the crops and the situation especially related to the winter crops that have been affected due to the shortage of labor force in several areas. This is an example over Spain that is currently integrated in the dashboard, and you can access it yourselves, and also a way of getting, let's say, a first impression of what the effects of the pandemic were due to the lockdown and due to the lack of workforce. In this graph, you can see the difference in the percentage of harvested parcels as a cumulative function in 2019, which is the red curve, and in 2020, which is the green curve. And you can see this difference signifying a much lower cumulative percentage of harvested parcels or area due to the shortage of workforce. Finally, Sentinel-3 and Sentinel-5B have been intensely used for deriving information related to air quality and water quality. These are some of the most popular indicators that are being accessed by the users of the dashboard. On the left-hand side, you can see a time comparison between September 2020, so just last month, and September 2019, and you can see differences in NO2. Of course, it's important to mention that on the dashboard, all these indicators are accompanied by an explanation that is being prepared by our science teams and is prepared in let's say regular plain language for people to understand, because there are several factors that are potential causes for these effects that we are seeing with our satellites. Finally, I will not go into details because Henrik is coming after, but I will just say that this is the latest indicator that is being added on the dashboard as we speak. So it will be very soon accessible for everyone to see. This is an indicator that came from the upscaling competition, and it refers to the truck detection prepared by Henrik. I will leave this to him. I'll just point out, you probably saw this picture before in Greta's presentation. I will just try to point out what were the key elements that facilitated us to obtain this product. So on the one hand, we're sitting on a base layer of EO data. So we have access to a lot of Earth observation information, but not just current data, also archive data that has been really useful for deriving a lot of baseline metrics for our economic indicators. So everything is happening on the cloud. This really facilitated our collaboration. And it really enabled us to have an agile approach to the development. We have all the processing tools available, so most of the development, or maybe all of the development, or all of the a good majority of the algorithms are running on the Euro Data Cube and are being taking advantage of the possibility to have user-defined algorithms and user-defined functions. And of course, the availability of APIs and the possibility to have a really seamless machine-to-machine communication has really facilitated the development and going into production so fast. The possibility to run machine learning on the Eurodata Cube, which was one of the questions, is also one of the key elements that enabled us to be able to go forward with the object detection and the derived indicators. So where we're going next, we're continuously adding new data. We're increasing the coverage, going to towards covering more member states, providing more indicators, and actually, this last box that you see here with international cooperation, this has been already going on. We have we are already coordinating the efforts with NASA and JAXA, and you can see this coordinated effort if you visit the eodashboard.org, which is this tri-agency deployment. This is my final slide. I just want to point out again that this is really a team effort, and to thank all the contributing companies and teams for this, including the science teams, and thank you for your attention. I'm really open for questions. Thank you.
Thank you very much, Anka. Very impressive indeed, I have to say. Absolutely. I am now looking, gleaning to the time. We have two more presentations. About that will be about half an hour. I just want us to be conscious about how much time to spend now in answering some questions and what we can then make sure that we discuss at the end. Just a FYI on that. I have a question here that it goes directly to you, Isa. So Anka, I think, will ESA support targeted also ground data collection on data gaps? You see the context, the data and modeling are both very biased towards areas and topics of interest. There's a tons more data forest than on wetlands and so on. So do you have any, now based on your experience with your example here, that showed a huge capacity for you to actually mobilize a large community. Will this be something that you are considering?
Definitely, in many of the indicators, especially the environmental ones, the baselines that have been used to understand if what is happening is, let's say, better or worse than this baseline. Most of this data comes from in situ measurements, so it's based on complementary sensors. There are quite a number of campaigns that are being supported by ESA, not in the context of this initiative, but all the data that is coming from these campaigns can, of course, support this.
I will come back to that issue actually at the end in the discussion at the end. Do I see more questions here? No. Then I suggest that we just jump to the next speaker. And Anka, you will be able to stay with us, right, Anka? So you can take part in answering questions and discuss later, right? Yes. Thank you so much. And Gerhard, can you then give Katerina she has the ball already. Now we are starting to use this term in this software, the WebEx. Katerina, I invite you to introduce yourself a little bit first and then give us your presentation.
Okay, thank you very much, Bente. Hello to everybody. I'm pleased to be here with you today. And just to introduce myself quickly, I am Katarina Yupova from Prague, Czech Republic, and I'm working for GSAT company, which is leader of the Geoinformation Services and Remote Sensing in the Czech Republic. And in this conference, I'm here because we are GSAT is a part of EDC consortium. And our role is somehow to demonstrate or to simulate users of the Eurodata Cube platform. So it's what my presentation will be about, to show you some very practical example of the use case, how the user can exploit the EDC platform for these benefits. So I'll share my screen now.
It's coming.
Okay, is it okay for you? Can you see my presentation?
Absolutely. Go ahead.
Okay, perfect. So as I declared, my presentation is about implementation of third-party processor into the EDC, or integration into the EDC platform. And the processor is called GRISE. It's a kind of classificator of Sentinel-1 imageries into the RISE maps. And our work somehow represents integration of a real-world app into the EurodataQ platform. So it's a kind of a user story, or demonstrator of a user story, which I will present to you now. Just to explain, the GRISE application is not prepared by GSAT. It's prepared, the authors of the applications are CSBO team, GRISE team from CSBO France, and so they prepared and provided us by the processor, GRISE processor, and our task was to integrate this processor into the EurodataQ platform. So it was kind of complicated, because every time you are not a producer or a processor or author or processor, it's always more difficult. But still, I think it was at the end quite easy to integrate the processor into the EDC, and very beneficial. This is a short description of the processor, its components, and also a workflow about how it works. It just produces the race maps from the based on Sentinel-1 imageries, radar imageries, and there are a few consecutive steps in which the processor works. First is the download of Sentinel-1 scenes. Then the second step is the preprocessing of the Sentinel-1 radar imageries. And the third step is the classification of the, let's say, this time series of Sentinel-1 imageries into the GRISE fields maps. Originally, these steps were secured by tools developed by CNES or CSBO, and during the integration, we aim to transfer most of the steps to the tools which are offered by EurodataQ platform. Technically, the processor is written in Python free scripts. And also it contains a speckle filtering module, which is compiled into Orfeo toolbox. And what we did with the processor was that we compiled whole processor together, all the parts, to be able to Dockerize it and integrate the processor easily, let's say technically easily, into the EurodataQ platform. The way how it's implemented technically into the EDC at the moment is that it's integrated as a single Docker container, and let's say the interactive parameterization of the process is accessible to the user through Jupyter Notebook in the frame of EOX hubs. So it's kind of interactive way how the user can use the processor now, set, for example, area of interest or time range of interest. And the results are generated, which are GeoTIFF maps, which are then stored also in the EOX hub and can be also downloaded by the user. There were a few main steps which should, from the original workflow, which we, let's say, managed to replace by the steps and or features and tools which are available in the frame of EDC. First, the download or access to Sentinel-1 data, which was originally realized from the CNES Sentinel data repository, was replaced with a direct link to Sentinel Hub, which is a part of the Eurodata Cube. So it was one of the essential steps which we did, this replacement. Second, the pre-processing, let's say, part of the workflow, pre-processing of Sentinel imageries also was originally realized by the tools prepared by CNES, some open source tools. And what we did in the frame of this work was that we replaced most of these tools by the Sentinel API tools, which worked pretty well. And the only part which we reused from the original version of the processor was the multi-channel speckle filtering module, which is compiled in the frame of OTB, which was not possible to be replaced by any of the tools yet. And third, of course, what is one of the important features, let's say, which was used from the EDC was, of course, exploitation of the processing and storage capacity of the Eurodata Cube, which is very beneficial part for the user. So it was about, let's say, a technical implementation of the work, how the processor worked, how it was integrated on a technical way. And now I'll, let's say, show you quickly how the user can very easily add his app or, let's say, any kind of processor or anything into the Eurodata Cube platform. So this let's say step can be realized very easily because in the frame of Eurodata Cube website we do have a marketplace web page which can be used for integration of any application developed by the user. So if you create an account on this marketplace, you just use this feature, which is my contributions, and very easily add your app to the Eurodata Cube platform without, let's say, too much support from our team. So it's almost fully automated now, and it will be fully automated in, let's say, a very short time. You can, of course, set all details or define all details of your processor or your app, and there's a dedicated form for it. And when you submit the processor via this form, then the application appears again on the marketplace under your account, and there is a session which is called My App, so you can manage all around your application and version it and so on. And once you or any user submit his application in this way, it appears on the Eurodata Cube marketplace, and it's offered to any user. It can be either for free as a demonstrator, but usually the users will aim to let's say, to offer their apps with some price. Here I have to mention that the version of the GRISE processor, which is currently offered via the EDC marketplace, is still demo. It still needs to be validated and approved by the GRISE team from CSBO. So it's let's say the demo version, which needs to be approved. But it's fully functionable and it works properly, and so any user can test it. At the moment, it's offered for free, but we will discuss some pricing for this particular app in the future, of course. But typically, the user pays or the application pays for consumption of some processing capacity of Xcube and Sentinel Hub and so on when he uses the applications. And of course, any user can add some description for his application. And also, what is very important are the dependencies of the of the EDC which needs to be installed, which parts of the EDC, which services needs to be installed, which are connected to this application, which are used to this application, by this application, and so the user can run the application. He usually needs to install some other services of the EDC. And once the user deploys the application, it's, let's say, the third-party user, the one who wants to buy or try the application, your application, which is offered via the marketplace. Then he can easily access the application in the frame of his account on the EuroDataCube marketplace. You can see it here, like for example, GeoRise, and using a simple link or a link, the user can access to his workspace on the EuroDataCube platform. And in this case of the GeoRise processor, it's operated by the Jupyter notebook, as I already mentioned, and also there are some directories for the results to be stored and so on. So you can, let's say, run the whole processor and parameterize the process in the Jupyter notebook. You can set the area of interest and time range of your interest, and a few other parameters, and you can, let's say, control the process pretty good. And of course, you can generate and quickly overview results, which are the GeoRise maps, so kind of land cover classification based on the time series of the Sentinel-1 imageries in this case. And the last part of the process is that these results are stored in the EOX hub, in the EDC, and some dedicated directory, and so you can download the results anytime to your local working space or local working station. So just to summarize the main benefits of this integration, which we tested somehow, and which we think are more the best parts of say of the possibility for the users to be able to integrate their own applications with the EuroDataCube are as follows. First one is quick and easy access to Sentinel-1 scenes, because the Sentinel Hub is the part of the EuroDataCube, and the link with the Sentinel Hub and the Xcube works pretty good. So it is also one of the main reasons why the processing time was significantly decreased by 1/2 in this case of our test. Comparing to the version of the processor which we run locally at GSAT. And next, of course, the use of Sentinel Hub API tools for the preprocessing of Sentinel-1 imageries is also a big benefit, which was tested and appreciated. And obviously, you save your processing capacity on your working station and so on, and also save your storage space, which is obvious. So you can run the process remotely on the EDC, and you don't have any processing space locally. And but these are, let's say, technical benefits of whole integration. But most of all, I think what is the best benefit is that any user can offer his application on the EuroDataCube marketplace, and not only, of course, make it visible to wide community to wide EU community, because I think there will be a lot of users which will start to use this platform. So if anyone decides to offer this app via the EDC marketplace, it will be made widely visible. But of course, the user also can easily sell his application to the users this way. So I think it's a win-win thing for the users to integrate their applications into the EDC platform. So it's a short, let's say, summary of our experience, how we work with the platform and how we integrate it to the, let's say, third party application with the EuroDataCube platform.
Yeah. Thank you so much, Katarina. It's very interesting to see how a very concrete example have been using these resources. You mentioned several interesting topics I would like to take up later personally. I will have a glean to the questions here. I don't see any more now. Do you, Gerhard, see any more questions at this point?
Yes, there is one more question from Kremena Gocheva on a question to Isa. Actually, I was pinging Anka if she is willing to take this question.
Oh, well, we already answered that about the ISA support targeting data collection on data gaps.
Oh, I see. Sorry.
Yes, we already answered that. Yes.
Okay,
Yeah.
I'm sorry for that.
No, it's no worries. You will also stay with us, Katarina, right? Until the end?
Yeah, of course.
So we can, I have some questions, but I want to give the floor to Henrik also, last but not least, so that you can show us your example. I think Grega also briefly mentioned it earlier, but now we can dive deeper into it. So Henrik, I give the floor to you. Introduce yourself a little bit before you start your presentation. And my guess is that we will have about 15 minutes for discussion after your presentation. So do indeed ask questions in the Q&A. And yeah, one more thing I forgot to tell you, that of course, you can be given the microphone here and you can just raise your hand also. That's another option. So we will try to follow what you write in the chat and read your questions, but we will also be able to see you're raising your hand, and then Gerhard will be generous enough to give you the microphone one after the other. Okay, Henrik, the floor is yours.
Okay, thank you very much. So my name is Henrik Fisser, and I'm studying Applied Earth Observation and Geoanalysis at the University of Würzburg in collaboration with the German Aerospace Center. In the final year of my master's. So you all know about what I'm going to talk, the Sentinel-2 track detection. Please give a short confirmation that you see that.
We see it, and there it's in presentation mode.
All right. So all I'm going to present today was implemented on EuroDataCube resources. The topic started some months ago when I was exploring Sentinel-2 data in EO browser, so on Sentinel Hub basically, and I saw those objects somehow like moving because they are in temporally variant. So my assumption was, okay, we have some interesting objects that apparently haven't been detected before with Sentinel-2 data. Now, if we could look a bit closer, we see that rainbow shape, let's say, from red into green into blue, those small objects with just like 8 to 10 pixels. Now, why is that? The Sentinel-2 multispectral instrument comes with certain parallax effects due to the sensor geometry. And that means at the end that these bands are not acquired at the same time. So while an object on the ground is moving, as you see it here on the right, a track, it will be seen by Sentinel-2 at slightly different times. And this so-called interband parallax angle is very specific for the band combinations. For example, here on the left, you see those band combinations, red versus blue and green versus blue, because that's of most interest for this topic. Now, this effect has been used already for some other objects with Sentinel-2. Generally, the effect has been used with other sensors as well. However, Sentinel-2, there's just a few publications on this, targeting, for example, airplanes, clouds, and also ships. Down here, you see an airplane, for example, where not only the movement effect comes into the game, but also an altitude effect. Now, why am I assuming that those objects are actually tracks? If we look at a Sentinel-2 10 by 10 meters pixel, we see that a truck of general size, about 19 meters length in the European Union, would cover about 25% of a single pixel. So compared to that, a car is really, really small, so it's much less than that. So the assumption seeing these objects of a similar size must be these must be the largest objects moving on roads, and these are trucks. However, we see, for example, a caravan would also be like 19% of a pixel. So it's at the end, looking at a single pixel, it will be of similar size as a truck. However, I will talk a bit more about this in the validation. Right now, this is just an assumption, so before when starting. Now, if we want to detect these objects on roads, the idea is essentially just targeting the most outstanding part of these objects. And my conclusion was at the beginning that this must be actually the blue part of that those objects, because high blue reflectance in the RGB is quite rare over land surfaces. You see that depicted here on the lower left, where blue is superior towards the green and the red. And then we can calculate ratios based on that, and calculate thresholds with which we can determine a certain range of these ratios for the blue part of the tracks, let's say, and actually delineate it. So it's just a simple concept like band ratio, like normalized difference vegetation index. Overall, that's the method implemented then first in a basic version on EO browser, so on Sentinel Hub, and then later on Eurodata Cube, which I'm going to talk about later. We have background filtering based on OpenStreetMap roads, and then a reflectance filter. Those two RGB ratios, which is actually targeting the tracks, and then we get a spatial filter in order to eliminate some doubles and triples. How does it look like? It's essentially to RGB. We apply the road filter, the reflectance filter. Also like to avoid snow or any vegetation, any water, whatever might be there. And we target the objects with the ratios, and then finally eliminate doubles or triples, so that we get 1 pixel per object. Just a visual impression how that looks. Some examples across Europe. I think you have seen that in the previous presentations already, some insight. Now, regarding the validation, there's different data sources possible, and in this case, I used German automatic traffic count stations. So these stations actually count what type of vehicles pass by on motorways, but also on primary roads. Then I used this hourly data in order to get a number of trucks that pass by the station around, like temporarily around the acquisition of Sentinel-2, and then count the detected trucks that are actually in reach of the station. So in reach in terms of speed, 90 kilometers per hour, and then these counts are compared with the count station counts. And then what we see here is the result of that task. What is most outstanding, I think, is that the red bar shows the true cars, and that's actually much above the true trucks and also much above the Sentinel-2 trucks. So one could assume, well, maybe we see even cars, maybe they also get this outstanding reflectance pattern, but this indicates, actually, this suggests that this is not the case, and we are actually targeting trucks, and also we are actually getting close to the numbers that really pass by according to that validation method. So we see that a mean 78% of the trucks were also recognized based on the Sentinel-2 method at these 4 stations. However, there are also unfavorable conditions like high cloud cover, for example, and you know that depending on the cloud masking method, you often get certain residuals, and that might lead to confusions. Here on the right, you see essentially 2 trucks are lower than the true trucks. However, most likely should be even much lower given some false positives there. Now, the overall question of the work during the last month, so upscaling that on the European Union scale, were the changes of truck traffic during COVID in order to integrate this information and explore that information in the race dashboard of ESA. All this I've been presenting was implemented on Eurodata Cube. So the processing on EU scale, of course, required certain capabilities and certain capacities, processing power that was offered through the resource of Eurodata Cube. And there it was Jupyter-led hosted by EOX, in which everything was developed in Python. And then we get into Xcube, or specifically Xcube SH, so the Sentinel Hub version of Xcube, let's say, or the bridge to Sentinel Hub that gets the Sentinel-2 data from Sentinel Hub, and then we can go down from Xcube and retrieve our data from there, do our analysis just using the general packages like Xarray, NumPy, or whatever we like to use. So the computations were parallelized and several processes were run in parallel. All in all, the processing for the whole European Union, so multiple coverages of the European Union, because we want to compare different periods, took 14 days. Now, what are these periods? Going into the methodology of the EU scale processing, of course, we have the COVID year 2020, where a period between April and June was processed, and then as well as best processed were the periods from 2017, 2018, 2019, so the same period. And at the end, we have some baseline years, baseline periods that we can compare with the COVID period. That was implemented. If you look at the periods, we would have an Xcube Sentinel-2 data cube, from which we can retrieve the acquisition and decide if we want to use that acquisition and do the detection, add that detection again on the period level to a stack of detections. And then at the end, these detections are normalized by the number of observations in a certain period and area. There are two conventions that are also important, is that we just process Tuesdays, Wednesdays, and Thursdays because they are most comparable in terms of truck counts, and also didn't process all available acquisitions during that time, but yeah, I mean, due to constraints, still there had to be some satisfaction threshold. Now, if we look at the baseline, which is important for the interpretation of the results, we should keep in mind that there's an uncertainty of the baseline, which is mainly the variability of the baseline, assuming that truck traffic is actually quite stable, looking at consecutive years. And we see that in smaller countries with overall less truck traffic, the uncertainty of the baseline is also higher. So these are the results. Starting with the motorways, we have a minus of 15% compared to the baseline. And what is the baseline value? So we see three values here on the left. There's 17, 18, 19, but the baseline value is then the median of these 3 years in order to account for some variability, as I showed in the uncertainty, and as we see it here as well. For primary and trunks, that is minus 7% COVID versus the baseline years. However, with both examples here, motorways and primary and trunks, we see quite a variability across Europe. So it is very interesting to actually go into detail, and that will also be possible doing that on the race dashboard later. So for each and every user, going into AOIs such as the Brenner motorway, a very, very important, one of the most important motorways in Europe in terms of truck load. And we see that there's a minus of 11% in 2020 period compared with the baseline value, which agrees actually well with count of the toll station on the A13 at the Brenner. Even more higher decline is seen on another important motorway in the center of Europe, connecting Calais with Belgium and Western Germany. So Calais, also connection to Great Britain, and we see minus 42% truck traffic, and similar Spain, France, connecting northern Spain with southern France, a minus of 20%. These are just some examples, but you will be able to explore that yourself. Now, overall, the question is, can we actually relate truck traffic derived from Sentinel-2 data with economy? And I wouldn't say that we are already specifically there, but at least there's this relationship. And we look at the economic growth forecast of the European Commission for 2020, see that it is in a similar magnitude. So of all minus 11% trucks on the European scale, and the economic growth forecast is a negative growth of between 6 and 12%. Now, when interpreting these results, I think it's important to keep in mind that as some aggregation is needed due to cloud cover and so on, in some areas we might see lockdown effects, and other areas we will see catch-up effects. So that's quite important. Also, in general, related to the method, it is a bit prone to false positives and hazy conditions. So also that is an uncertainty introduced, and then we don't achieve accurate absolute counts. Although you saw the validation with the 4 stations, it already looks quite good, and we can actually be quite sure that these are indeed trucks. However, some further validation, and also on a larger scale in different countries and so on, will be required. Now, in order to combat some of these remaining challenges, I'm suggesting to actually use deep learning methods in the future. So currently starting to work on that, using a convolutional neural network, for example, in order to not just detect that blue part, but even the more characteristic picture of the whole object. And then we might yield more precise absolute counts, which is quite interesting regarding secondary information we could derive actually from these large, huge truck data sets on large scale even, such as emissions of NO2, for example, but also aerosols. Then would be also interesting to focus more on base-specific detection, for example, because that can also be used in models that look into the emissions, for example. And all this must be then also validated on a larger extent. Now, another thing going on, as you know, is the integration into the RAISE dashboard. So in the near future, you will be actually able to explore the indicator, this economic indicator yourself, and use your own AOIs, get the number of trucks and the change between the COVID period and the baseline periods the other years. Now, these are the Python libraries used, credits to that, and also thanks to EuroDataCube for supporting that, and some resources. So thank you very much. I'm looking forward to some questions.
Thank you, Henrik. A very exciting example on how you surprisingly can use satellite data. Do we have any questions? I don't see any. I think I will give the floor to you then, Gerhard, for introducing the discussion. FYI, I have to go in 12 minutes, but you can continue, of course, without me afterwards. But Gerhard, do you want to introduce the discussion?
Well, the discussion should be around statements of the audience or of the panelists. Let me make some more short statements. First of all, EuroDataCube as a project has been funded by ESA, so we should acknowledge this. ESA is playing the role of a catalyst here, and industry is supposed to take over and bring the EuroDataCube services into sustainability. So that's ongoing at the moment. We have in the audience Philippe Monniot, who is the technical officer of ESA, following the EuroDataCube activity on ESA side, and I want to thank say thank you to Philippe as well. Maybe Philippe wants to say something. I pinged him, but he didn't respond. Doesn't seem to be the case.
You can chip
Right.
in. Yeah. Do you see any hands raised, Gerhard? No? No.
Okay. So again, thanks to Isa, and thanks to this opportunity. Another thing that I wanted just to announce, and for this purpose, I'm quickly share my screen.
You probably have to make yourself the presenters.
Yeah,
Mr. Hendrik.
I'm the presenter, but
Yeah.
okay, so sorry, fighting a bit with too many windows here. Sharing screen is what I want to do.
You are there. You go.
There it is. Okay. That's the wrong one. Okay, so that's what I wanted to show. Most of you knew Eurisi, and I just wanted to say that that EuroDataCube has been, and I'm very happy about this, has been shortlisted candidate for the 2020 Hubert Curien Award. For those who know Eurisi, the prestigious organization supporting, in particular, new people working in Earth observation initiatives, new initiatives, and the, well, I'm still stuck. Yeah, and this is the jury, and you read a lot of honorable persons there. They are at the moment in the process of selecting from the nominees, and we hope, of course, that EuroDataCube will come out first. So congratulations to the EuroDataCube team, and to get rid of the sharing now. Oh, am I still here?
Yes, you are.
Yeah, I lost my.
You lost your presentation?
Now here we are.
Okay.
And so these were the things that I just wanted to add. And last but not least, I wanted to remind you that this afternoon there is a hands-on tutorial, interactive training course organized by EuroDataCube, and as a second side event this afternoon. These were the three things that I wanted to add on my side.
Yeah, so now I see that Philip Munoz, he actually raised his hand, so I think you can give him the authority to speak.
Yes, I will now have to get this. Just a second.
Maybe I can do it?
No, you don't.
No, I can't.
Have to open the list of all participants, scroll down to Philip, and the list of participants has been 72 as far in the audience. Okay.
I see him at the top. If you have the list of attendees, there are 4 displayed, and then Philip just been below Cremena in the list of attendees. I think you can actually search for attendees as well. Yes, you can, if you click on view all attendees, and then
I did that already.
Okay, and then on top there you can there's a find, and then you can search for Philip.
Okay, now I've got him. Here we are. Philip, you're on.
Hello. Hello. So I thought I was the guy unable to use WebEx, but actually it's not so easy. I dropped it out. So thank you for the organization of this side event. I think we had already an overview. I think 2 hours almost now. It's also short to demonstrate all the potentialities of the service. It's a challenge because, as you mentioned, we put this, together a number of companies that sure were able to work so far on technical project for ESA, either on their own or sometime together. But definitely the Eurodata Cubes bring further steps in putting the industry together and not only developing for ESA, but be sponsored to deliver a service, an industrial service. So we're still, Gerhard, now in discussion internally to see in the next months how we can improve, but I think technically we are there. This is the first point, which is very important. Second point, we have you have demonstrated to have collected already some use cases which are quite promising and show already the potentiality of the service. For sure, it will improve in the next months. Also, the organization of the let's say operational setup, the governance of the platform. Many things need to be improved anyhow, but we are on the good track anyway. So I would like to thank you. And hope in the next side event, maybe next year, I don't know, wherever, to onboard more and more use cases and value adders able to demonstrate that the service is valuable, as we believe. And that's all for me.
Excellent. I have now a question for, while we are waiting. So you now know how it works. You can raise your hand and Gerhard will give you the floor. While you are thinking about it, I have a question for you, Anka, and that is because you actually worked on a project called NextGeos, the data hub and platform earlier. So I have seen, the way I know this data cube and the fact that now we have the data catalog in cataloging metadata. So and including in this metadata is an access point to data, different types of data, not only the Sentinel data, which of course you have here on the data cube, access via the data cube, but we also have in situ data and auxiliary data catalog there. And we do have the Open Search API, but so that you can do search. But do you see any possibilities of exploiting these resources together to be able to do even more processing and create more applications and services?
I think there are many opportunities brought by these technologies that you mentioned. Having open APIs and having, let's say, a simple way of bringing together different resources in a federated way is the way to go forward, and definitely including more data sources and having the possibility to really find what you need for your application and what is relevant for your application is definitely good to have such a catalog and services such as the ones provided by NextGeos. How the technical integration can be made, maybe this is something more for Grega, but definitely there are synergies, yeah.
Thank you. I just posted the link to the catalog so that you, if you're interested here, that you can actually take a look at how it is looking now. And you can learn more about it actually next week. Just to plug that, we have a big summit where we explain in more detail. But because I do see really some good potential in using these resources collectively. And I know you, Gerhard, we were discussing this a little bit prior to this meeting also, that this might be a good way of combining resources, actually using the NextGeos platform as a testing together with the data cubes. I see that both are possible, but then scaling it up by using, for instance, the different DSs. I saw that you were listing, was it you, Anka, you listed Mundi as one of the DSs, at least, that were in an example. I don't know. Probably it will be valid for all of the DSs, not to, skew that, but yeah. Okay. Do we have more questions? Not yet. I shoot one more for you, Katerina. I promised you a question. Well, an observation that you were you were actually talking about that your application now were free, right? It was a free application, but you were planning to commercialize it. And I see that there are several applications and services that will be free on this marketplace. How do you, are you considering, and maybe this is not only for you, Katarina, but for all of you have using, and also for you to create the platform, do you invite beta users? I mean, before you start to fully commercialize, is this a place that where beta users are welcome? Katarina? Yeah.
Okay, I think for commercialization, I think it's a more question for whole consortium, especially for Grega, maybe about the strategy. And from my view, I think there's a big potential for commercialization. I think it's the main aim of, let's say, not only of this project, but also the strategy of ESA and so on, to get some real customers, because to exploit somehow data which Commission and ESA is let's say, acquiring and offering to, let's say, some service providers from the field of GIS and remote sensing, and to use this data and services for some real use of real users, to bring some real profit to someone. And if this will be suited this way, that will really target, let's say, the applications which are useful for someone. I think this is the point how the commercialization can work. So I think it's very important.
Thank you.
Gregor did not get this invitation to answer. Yes, he is.
No, I listened to it, but I think that Katarina nicely answered, and I have nothing to add. I mean, obviously, that is the point of the Eurodata Cube, is that it does provide access to the services, both free and commercial ones. And whoever wants to generate revenue on top of it, more than welcome, and we are happy to support it. So I think Katarina nicely answered.
Yeah, thank you. And now I have to apologize to leave you guys, because I need to be, I'm promised to be somewhere else. It has been super interesting. Susan, thank you so much to all the speakers. And Gerard, you can conclude this event. I'm sure you can. Until the next time. You're mute, Gerard.
Thank you, Bente, for being with us and moderating this event so nicely. What remains to me is only to say thanks a lot to all the panelists, to the interesting contributions. We're looking forward to get updates on Eurodata Cube as it evolves. I would also like to say thank you to all the participants in the audience. We counted as a maximum of 72 external participants, and they all, or most of them, stayed on for the whole duration of the 2 hours events. Thanks to all of them.
And don't forget to invite everyone to the afternoon session, right? To the hands-on.
I did already, Gregor. I can also, I did this already, but I can bring this up on the screen just for everybody to see what's going to happen this afternoon. Just a second. Here we are. Eurodata Cube hands-on tutorial and training session this afternoon, starting 2:30, 1.5 hours, and you will get an introduction in how to get started with the Eurodata Cube, how you can get registered, and then also get hands-on training on the notebooks that are available, some of the notebooks that are available, and how to use the GeoDB database. So with this, I would say we conclude this side event, Phi-Week 2020. Thanks again to everybody and enjoy your lunch break. Bye-bye.
Thank you. Bye.
Thank you. Bye.
Bye bye. Thanks.
Thank you very much. Bye.